Has this ever happened to you? In today's vastly connected world, if you get stolen from, literally anyone in the world could be the culprit. Maybe it's as innocent as this pantry robbery, or as terrible as your savings account. The fact remains that finding a solution to this issue of mass stealing is imperative. The mystery of who stole your stuff and how to stop them is a difficult one to solve, unless somehow you had a device that could not only figure out who is stealing from you, but to stop them from doing it. Introducing Detective Deadbolt, the intelligent security system that keeps your doors safe and secure. Detective Deadbolt, at its simplest, is an automatic deadbolt for any entrance. In this example, we have it attached to a pantry door. Using its advanced image recognition technology, it can detect the faces of familiar people and allow them access to the food inside, but more on that later.
Our project was inspired by the thievery of smaller siblings, but as we developed the idea, we realized that it could be much more widely applicable to home security throughout the world. As we created the preliminary designs, we had several different ideas that we unfortunately could not implement due to time constraints. However, we were able to successfully implement a facial recognition system that could output data based on the identities of the recognized faces.
As we continued to design and model the components of the system, we ran into some software issues early on that severely slowed down our progress for several hours.
I don't know how much we've thought about this, but we've been trying to install Python onto this Raspberry Pi for like literally 8 hours at this point.
An error in the installation of Python on the default installation of the Raspberry Pi led us down a long and frustrating rabbit hole of incompatible versions, manual installations, and false epiphanies.
While we dealt with that, we took frequent breaks to focus on other important parts of our project, including modeling our mechanical components to 3D print. With us ping-ponging back and forth between Python libraries and 3D prints, our productivity became a roller coaster over time. Then, sometime after 2 a.m., we made a breakthrough. We finally found the solution to our Python problem, and it turned out to be the simplest one that had been staring us in the face for the entire time.
I wish I knew this like 5 hours ago.
After a few of our prints finished, we mounted the first component onto the door, along with the panel that would later hold the bulk of the system. Printing the next few parts, we realized that we had to move the panel to the other side of the door for our design to function properly. Why is the mechanism for the deadbolt on that side?
With the rest of our parts printed and with some extras, we mounted the remainders of the rack and pinion mechanism onto the door, followed an hour or two later by the Raspberry Pi as the code was finalized. Around 6:30, we finally had a working system, and it was time to test.
And here are our testers now, modeling a detective deadbolt system mounted on an otherwise vulnerable pantry door. As you can see here...
Yeah, I am a person that is allowed in the pantry.
When it detects an allow listed face, Detective Deadbolt will open the door so the pantry can be easily accessed. On the other hand, when it detects a deny listed face...
I'm on the deny list. I'm not allowed in.
The system will immediately sound an alarm and lock the door once again, ensuring that the pantry is completely safe and secure. Besides that, if a face is not registered in Detective Deadbolt's database, it will act the same way as it does for a deny-listed face, so unfamiliar potential burglars will still be denied access.
We also made this simple admin panel to allow you to close and open the deadbolt remotely from any place, as long as you can connect to the Raspberry Pi. It is run locally on the Raspberry Pi, and we plan to add a like camera feed, live camera feed, like history if who's come, basically all like the nice features there. We will be implementing that soon as well.
But our current design of Detective Deadbolt is just the beginning. We have big plans to expand the convenience, configurability, and functionality of the system in the future. For example, with a mobile app and a GUI that can access and store faces recognized by the system, it'll be much easier to find out who's been knocking at your doors when you're not looking. The system might also benefit from the implementation of some of our earlier ideas, including voice recognition and a lie detector. This would ensure that the person accessing your doors is who they say they are. A final goal for our improvement of Detective Deadbolt is compactness and portability. While our current size setup might be somewhat rudimentary, the design can be improved and expanded to all shapes and sizes of doors with a more compact case and portable panel system.